All attendees are in listen-only mode.
Hey, good evening, everyone. We'll be starting in 5 minutes, and thank you for your attendance. Rob, just wanted to do a mic sound check. Testing.
Hey, Rodney.
Hey, Rob, can you hear me?
I can hear you.
Awesome. Okay. And for those of you who are just joining us, we'll be beginning in a few minutes' time. All right, good evening, everyone. My name is Rodney Chai, and I'm here tonight with Rob Magnia, and we're going to go through the January 7 winter storm, which was the first major winter storm of the season. And then after that, we would give you kind of like a sneak peek of what could potentially be our next winter storm this weekend. And so once again, thank you so much for joining us tonight. We appreciate your attendance and time. And so, you know, if you if this is your first time, you can always check out our webinars at the URL on the top left corner of your screen. And if you miss one of our webinars and wanted to look at it, you can always review the webinar on our YouTube page on the bottom left corner. And that coming soon, I think. So that is a little bit outdated, but I think this weekend storm, if it were to materialize, then we'll be having a webinar on that as well. So as usual, Joe is not able to join us tonight. So, but if you have any feedback or want to be added to our email list, be sure to email Joe, and his email address is on the bottom right corner. So once again, my name is Ronnie Chai. I'm a meteorologist at National Weather Service Boston, and with me tonight is my co-worker Rob Magnia, and we'll be presenting to you the event review for the January 7th winter storm, which was our first major winter storm of the season. Let's see. So Rob, why not you go ahead and take it from here?
Awesome. Thank you, Rodney. Good evening, everyone. Again, my name is Rob Magnia. I work with Rodney at the National Weather Service in Boston. So thanks, everyone, for joining tonight. So what you're seeing here, I believe this is a snapshot from one of the webcams we like to use down in Martha's Vineyard by the Martha's Vineyard Ferry. So even the islands got their fair share of snowfall with this event. You can see the visibility down there, pretty poor with the snow coming down. And I think this was on Friday morning on the 7th. And then this video was taken by Rodney, and this was actually taken right up the street from me in Walpole at a Cumberland Farms right at 4:30 in the morning when a lot of the action was starting to settle in. You can see these big, thick dendritic snowflakes starting to fall, starting to accumulate down there around 4:30 in the morning. And this was just the beginning of kind of the intense snowfall that we saw for portions of Norfolk County and all the way southwestward, all the way as far southwest as New Haven, Connecticut. There was a pretty narrow area where we were seeing snowfall at this intensity. So something that was kind of unique about this event was, some of the snowfall totals that we got were pretty impressive, up to a foot or more from a relatively weak system that was actually moving pretty fast as well. Typically when we get these, high impact, heavy snowfall events in southern New England, we're usually getting them from, intense low pressure systems that rapidly intensify over the Atlantic waters as they're approaching the Northeast. And usually their pressures are getting down to maybe 980, 970 millibars, and snowing for a long duration of time, slow moving storms. But in this case, we only had a 996 millibar low, and it was in and out of here in a hurry and was able to dump, a good amount of snow over a pretty significant area in a pretty short amount of time. So that's kind of what we're going to talk about for the first half here anyway. So just the highlights again, it was a quick hitting winter storm, but the big reason it was so impactful is because we had snowfall rates of up to 1 to 2 inches per hour for the few hours that this storm is moving through the area. And it was coinciding with the morning commute for eastern Massachusetts and Rhode Island, which can always exacerbate the impacts with these storms. And it was also kind of our first major winter storm of the season. We haven't seen snowfall accumulations to this point this winter so far. So here's a nice shot of the radar imagery from K-Box right next to our office in Norton, Massachusetts. And this was kind of on the tail end of the event where the South Shore and all the way down to the South Coast, those areas were starting to get their fair share of the heavy snowfall, which you can kind of see in the darker shadings of green kind of extending all the way up towards the Hingham, Cohasset area and southwestward all the way down to Newport and New Bedford. And this was kind of during the last hour or two of the storm as the low pressure system was starting to pull away over the Atlantic waters. So now we'll just talk about some of the model output and some of the signals that we saw that were giving us the heads up that this, despite being a fairly weak, fast-moving system, could be a potentially impactful event. So this is from one of our high-resolution ensemble models, the HREF. And what we're looking at here is the wind speeds and temperatures at 700 millibars, which is kind of in the mid-levels of the atmosphere, and it's an area we like to look at for potential forcing that we're going to need to generate either intense precipitation or intense snowfall. So it's not always enough just to have kind of the obvious ingredients for snowfall with moisture and lift and cold temperatures. You want that forcing or that lift to occur in a very specific area in the upper atmosphere, and generally you want it to occur between areas in the upper atmosphere where the temperatures are between -10 and -20 degrees Celsius, because that's what we call the snow growth region. When you get strong forcing in that region is when you can maximize your snow to liquid ratios to get intense snowfall. So kind of what you're seeing here if you take note of the wind barbs kind of over the south coast of southern New England, notice how they're oriented almost perpendicular to the red lines, which represent constant temperature. Those are called isotherms. So that indicates strong thermal advection, and that's kind of an ingredient for generating frontogenesis, which is something you may have heard us talk about before, often referred to as winter's hammer. When you get these strong areas of frontogenesis set up, it becomes a signal for not only the potential for heavy snowfall, but for where heavy snowfall can occur. And you're generally looking just to the northwest of where the strongest thermal advection or frontogenesis is occurring for where you could get these areas of locally heavy snowfall setting up. So this image lines up pretty close to what happened, where you see that kind of tight gradient of temperatures and wind speeds kind of along the south coast and northeastward into through northern Rhode Island and up into the South Shore of Massachusetts. And again here, this is actually the values of frontogenesis now, instead of just looking at the temperatures and the winds. And the frontogenesis is denoted by these purple contours that we're seeing. So you can see this narrow area of strong frontogenesis over southern Connecticut. And this was forecast for the early portions of the event. And this almost lines up exactly with where we had the heaviest snowfall for this event. And now this is just we could talk about that one, Rodney, real quick. So this is just forecast for kind of the mid-morning on Friday, and you see that frontogenesis band start to pivot. So that's significant because this kind of gave us an indicator that the locally heavy snowfall might not just be confined to that one narrow area. When you have these areas of frontogenesis pivot like that, you're adding more distribution for where the heavier snowfall could occur. So you had kind of on the last frame with the stronger frontogenesis over southern Connecticut and up into Boston, and in this frame you have it over kind of the South Shore and parts of southern Rhode Island. So this was kind of another signal that we might have the potential to see a few areas seeing some locally heavy snowfall with this event. Now this is another product we like to look at in the extended. So this was actually at 60 hours out. So this was about 2.5 days before the event. And this is the WSSI product, and WSSI stands for Winter Storm Severity Index. And this product was heavily developed by actually Rodney's and I boss Andy Nash. He's played a big role in making this come to life, and it's been a really great tool. But it essentially measures the overall impact that you can expect from winter storm. It takes into account things like blowing snow, snow load, heavy snow, potentials for flash freeze, and in certain cases, potential for freezing rain. So this is kind of a new product we use that is probabilistic in nature, indicating, in this sense, 2.5 days out that there's around a 40% chance of seeing moderate impacts associated with this storm, and also kind of giving us a signal that the higher likelihoods would be across portions of eastern Connecticut, northern Rhode Island, portions of the South Shore, and Norfolk County. So this is kind of one of the first cuts of the snowfall forecast. We were kind of honing in on the areas we just talked about on the last couple of slides. Northern Connecticut, Rhode Island, eastern Massachusetts kind of getting the brunt of the snowfall, with us being a little bit more generous to the South Shore. But at the time we were forecasting about 6 to 8 inches. So this is a forecast, and at this point we're about a day and a half away from the event. The NBM, the National Blend of Models, which is kind of an ensemble model that we use, and this is the 50th percentile, kind of the average of a bunch of model members to kind of give us the idea of what the most likely outcome was going to be. So at a day and a half out, things were still kind of honing in on the South Shore, and even up into portions of the North Shore, with generally that 6 to 8 inches. And then looking at the NBM 90th percentile, this is what we kind of like to use to get an idea of what the worst case scenario might be. So according to this ensemble, 90% of the members that make up this average kind of model were suggesting that the highest totals we're going to see would be anywhere between 8 to 11 inches across eastern Massachusetts and the South Shore. And it's also important to note too that these are also based off the snow ratios that are generated by the National Blend of Models. So again, using the probabilistic guidance here, the probability of 6 inches of snow or more, a day and a half before the event was, again, it was heavily focused on the South Shore. The models were really gung-ho on having this be the area of heavier snowfall, and perhaps up into the North Shore as well. And then even some pretty high probabilities of greater than 8 inches of snow in the 24-hour period, once again focused over the South Shore and North Shore, and kind of decreasing westward. So at this point, this is a run of the NBM, and at this point we were only 24 hours out. So notice how the NBM starts to change its narrative a little bit. In an hour by hour forecast, you start to see this kind of area of narrow, heavier snow over eastern Connecticut and northern Rhode Island. So, as the event got closer, we started to get a little bit of a signal that maybe the hotspot wouldn't necessarily be just over the South Shore, and that maybe we could see some heavier accumulations further west. So here's a sounding, kind of a snapshot of the vertical profile of the atmosphere. And again, kind of going back to what I was talking about a little bit earlier, where we're looking for specific ingredients to occur in specific levels of the atmosphere. So if you kind of turn your attention to the top of the chart where you see that red temperature line turn to yellow, that's the dendritic growth zone that we talked about earlier. And it's in this region that you want there to be a good amount of moisture, which we have in this case because of the line representing the dew point. When the green line and the red line are close together, that indicates moisture in the upper atmosphere. And then on the left side, the white line, that represents omega, which is essentially just a measurement of vertical motion. And the further left that line goes, the stronger vertical motion we have. So in this case, we see that we're having strong vertical motion in the dendritic growth zone or the snow growth zone, kind of giving us the potential for moderate to heavy snowfall. And again, here, this is an image from the North American mesoscale model. And again, we kind of can see in the mid-levels of the atmosphere, where the temperatures are between -15 and -20 degrees Celsius, we continue to see, the potential for strong upward motion and forcing that's going to be able to generate intense snowfall and intense snowfall rates. And also high snow to liquid ratios, which was kind of the one thing we missed on with this event, was underestimating how efficient the snowfall would be. So now I'm going to pass it back to Rodney, and Rodney's going to talk about the messaging with the event as well as what happened. So thanks, Rodney. I'll pass it to you.
Well, thank you, Rob. Let's talk about the messaging. So we issued a winter storm warning for the areas shown in pink, and winter weather advisories for the areas shown in purple. So pretty much we were most confident in 6 inches or more of snow for the areas under the winter storm warning. And really the biggest concern, was, even though this was a relatively fast moving system, in and out of here, in between 4 to 6 hours, the timing was very problematic, and the high potential for heavy snowfall rates of 1 to 2 inches per hour snowfall rate coinciding with the morning commute, really made this a very tricky forecast. And also from a messaging aspect, we really need to hit home the message that, if you don't need to travel, don't travel, because it could be very hazardous. And so we, ended up with the forecast of a broad 6 to 8 inches with localized 8 to 10. And as you can see in this, the forecast map that we put out on the eve of the storm, there were 6 to 8 localized 8 to 10 inches. And, sometimes given how the color map worked, we really wanted to, we did include a caveat saying that locally up to 10 inches possible. We were not at that point in time too sold on the possibility of a foot of snow or more. But you can see, again, this brought 6 to 8 inches, localized 10 inches. That's where we had our winter storm warning. And, and part of the difficulty with this storm is that, we know that there's going to be a heavy band of snow set up with 1 to 2 inches per hour snowfall rate. But it is very difficult to forecast exactly where the band is going to set up. We know it's going to be over eastern Massachusetts, maybe across Rhode Island, but it is a system whereby you need this band to set up before we know for sure which locations are going to get the heaviest snow. And with the morning update, actually, Rob he worked that overnight shift, and he did great job with the forecast. And the overnight crew put out an updated snowfall map as soon as they possibly could once the band actually set up, kind of really, I mean, across the I-95 corridor down into Rhode Island and Northeast Connecticut. And, once you were under that band, I mean, it's going to, pound for like 2 to 3 hours. And at the end, that was the area that ended up with the most amount of snow, as you will see in a little bit. So that was the message. And let's take a look at the Mezzo Analysis. And so, a lot of folks like to, focus on the surface map. Granted, that's a quick and dirty way of looking at things. But, it's always important to look at the upper level dynamics. And one way to put it is, does what is happening at 18,000 feet or even higher support what is going to happen on the ground? And so in this case, this is Storm Prediction Center Mezzo Analysis, kind of like a snapshot of the atmosphere at that given time. And you can see, we have the negatively tilted upper level trough. And for those of you who are wondering what a negatively tilted trough is, I encourage you to look at our Winter 101 webinar on our YouTube page. But in essence, if you have a trough axis that, if you draw a line through the kind of like the center of the trough, if it cuts from northwest to southeast, it is a negatively tilted trough. If it's a vertical line, it's neutral. So, you want a negatively tilted trough, for a good winter storm in our area. And also notice how you have those purple lines. So those purple lines, basically, that is what we call kind of an area of upper level divergence. So if you were to visualize the atmosphere in a three-dimensional form, so so this is, let's say this is 18,000 feet above sea level. Now, we talk about how for storms, you want rigorous upward vertical motion, and in order to get that, you need kind of like upper level divergence where you have air parcels kind of moving apart from each other. So if you think about it, you have convergence of air particles at the surface. They shoot up through the atmosphere, and then they kind of hit a ceiling through, near the tropopause, which is basically the top of the atmosphere to be interested in, and they kind of diverge. So it's kind of like a conveyor belt. So you have like a constant movement of air. So if you have intense upper level divergence, you're going to have pretty intense low level convergence at the surface, which leads to upward rising motion of air. So, and here's the surface map again. We looked at the map at 18,000 feet. This is at 0 feet, and you can see, like what Rob mentioned, it's not terribly impressive. It was a 996 low, nothing out of the ordinary. And so this is again at the surface with so the black numbers are the temperature, air temperature, and the blue numbers are the dew point temperature. So, and the red numbers that's the wind gust in miles per hour. So again, kind of like a weak low pressure system. You can see areas towards Cape Cod Canal. They are kind of like flirting with the freezing mark. 32, 33 in Plymouth, 33 degrees in Martha's Vineyard, and then further west you get temperatures in the 20s. So once again, notice the negatively tilted trough, and the areas highlighted in purple, those are the frontogenesis. So in this case, that's 700 to 500 millibars. So think, the level between 10,000 feet and 18,000 feet. Now, when you look at the map like this, so this is again upper level map, and areas to the north and west of where the best frontogenesis forcing, that's where you get your heavy snow, and indeed that was what happened. Heavy snowfall rate again, kind of along the I-95 corridor as far west as 495. And this was at 9 a.m. mid-morning. You can see the frontogenesis really got going. Okay, so overlaying the frontogenetic band and the surface reflectivity, you can see that areas with that yellow reflectivity, that's the heavier snowfall rate, 1 to 2 inches per hour. You can kind of see, stretching from Providence County into Norfolk County, and actually into Metro Boston. And you can see again that's kind of on the northwestern edge of the best frontogenetic forcing. And why is that? Because that favors dendritic growth, and you want the nice dendrites for snow to accumulate efficiently, and that was what happened. And so as the event unfolded, we were actively also messaging our partners and putting it out on social media, and also we put out a special weather statement highlighting this area of almost quasi-stationary 1 to 2 inches per hour snowfall rate band. And I think some locations actually had localized 2 to 3 inches per hour snowfall rate. And that was a very impressive band, and the road crews were, unsurprisingly, they were having a hard time keeping up with snow removal because the snow was just coming down so quickly. And so this was the 6Z NAM sounding for Boston, valid 7 a.m. that morning, and you can see, so you had 30 units of omega in the favorable snow growth region. So usually when we get omega, that is kind of like above 20 units, that's pretty decent, and 30 units, that's very impressive. And you can see how the green line and the red line, they were kind of close to each other all the way to the surface. So the environment is fully saturated. So you have strong dynamics, and you also have very decent mid-level lapse rates. And this is actually 500 millibar, above 7 Celsius per kilometer. So that's there is some kind of elevated instability, and so combined with the forcing and the saturation, you're gonna thump snow. I mean, that's 1 to 2 inches per hour snowfall rate. So what happened? Unsurprisingly, that was pretty much where the heavy snowfall rate set up. If you're not in the band, pretty decent. You get 4 to 6 inches of snow across central and western Mass, and including towards Cape Cod Canal, and then for the outer Cape and Nantucket, they had mixing issues. It was really more rain than snow, but you can see very decent. I mean, wide swath of 8 to 12 inches with localized 12 to 15. So Blue Hill Co-op, there were 600 feet. So they got 15 inches of snow. So, I remember checking out Blue Hill. That was the most amount of snow I've seen in Blue Hill since I got to this office 3 years ago. And it was a skier's delight. That was a gift from Mother Nature. And so, and then the next day, the snow did not just stop at our border. It kind of affected much of the Northeast, and you can see this is snowfall analysis, and pretty much the entire Northeast was covered by snow. It didn't last long, but it was, finally, this looks much more like winter. And thankfully, because it was a dry, fluffy snow, there were not really, I mean, almost no power outages. I mean, that's, yeah, I mean, 1300 is nothing. So the key takeaways was, the main challenge with the forecast was the location of the heavy mesoscale band. We know with high confidence there's going to be 1 to 2 inches per hour snowfall rate set up somewhere across eastern Massachusetts. But it was a case whereby we really needed to wait for the band to set up before we know for sure where it is going to be. But I think, the office overall, we did well in communicating the impact on the morning commute. And, of course, we have no control over how, what the decisions makers decide. But, and a lot of you, I'm sure, know the schools were canceled that morning. And again, we put out, we as meteorologists, we put out the information to the best of our knowledge, communicate to the decision makers, and then they make the decision. So, overall, it was, I think a well messaged storm. So at this point, we're going to take any questions that you have, and then before we move on to the weather briefing. So if you have any questions, feel free to put it in the chat box. So we have this question from Ethan. So if reflectivity measures the intensity of precipitation, can it also measure the snowfall rate, or is it different from liquid precipitation? Rob, do you want to take that question?
Yeah, I can take that one, Rodney.
Okay, thank you.
So the reflectivity is kind of just isn't measuring precipitation rate, as you mentioned. It's just measuring the precipitation intensity. And we have what are called we use relationships between the reflectivity and the rainfall rate to kind of determine how intense precipitation is. And I believe the radar has an algorithm similar that it can switch over to an appropriate that's called a ZS relationship, which is a reflectivity to snowfall. So I guess to answer your question, it has the ability to kind of measure the intensity of both, but you have to be careful because, especially when you're in kind of marginal, or when you're in weather situations where precipitation type is an issue, rain versus snow, and you have these melting layers, you have to be careful when you're looking at the radar because as snowfall melts and turns to rain as it's falling through different levels of the atmosphere, it causes an effect called bright banding, where the radar appears to be returning stronger reflectivities, but the reflectivity is only stronger because you kind of have this melting snowflake. So that's, I guess, the only thing you have to be careful of when you're trying to use reflectivity as a measurement for intensity.
Well, thank you, Rob. We have another question from Mike. So do you use pattern recognition based on analogs from previous storms in forecasting storms like this?
I can take that one too, Rodney, if you don't mind.
Go for it.
So there is a really cool forecast. So based on analogs, right? So there's a really cool analog forecasting resource we have called CIPS, C-I-P-S. I forget what CIPS stands for, but essentially what it does is it gives you, it looks back at old data and old basically snapshots of the atmosphere. And, it comes up with, roughly 15 times that the atmosphere looks similar to what it does now. So, just for example, for the potential storm where Rodney's going to talk to you about for this weekend, I went and looked at this forecasting resource that kind of takes the average of the 15 most similar events to what the current atmosphere looks like right now, so you can get an idea of, what could happen. Now, I wouldn't say I really use it as a forecasting resource. Using analogs aren't the great forecast tools, but it at least gives you a little bit of insight into what might be possible. If that makes any sense.
Yeah, thank you. Great answer, Rob. So I think let's see. I think people are pretty quiet tonight. So I think if you have any more questions, feel free to throw them in the chat box. And without further ado, let's see. We have one more question from Wayne, actually. So I live several hundred feet from the ocean. The Lister storm, I measured 4.5 inches of snow, while several miles inland had 6 inches. So I conclude that ocean temperature, which was over 44 degrees, kept me warmer. Is that correct? And I think, yeah, Wayne, that's actually correct. I mean, that's whenever you had a nor'easter and relatively earlier on in the season, when the sea surface temperature is warmer and you get an onshore flow wind of the ocean, you're going to warm up the boundary layer, and that was actually one of the reasons why the outer cape actually did not get any snow out of this, because it was just a little too warm to snow. Even if it is snowing, it has a hard time accumulating. So I think that's a fair statement, Wayne. So okay, so like I said, if you have any more questions, feel free to throw them in the chat box, and I'm gonna talk about the potential winter storm this late Friday night into Saturday. So let's take a look. Let's see. So I'm going to start off with the slides that we have, and then we're going to take a look at some of the latest guidance. So I'm sure we monitor social media, and a lot of folks, a lot of folks are excited about the potential of this weekend, but we really have to at this point, we are still over 72 hours out. 72 hours is an eternity in the forecasting world, and there's still, cannot emphasize enough that there's still a lot of uncertainty with this system. What we can say is that it is highly unlikely there's going to be zero impact this weekend. So if you have any weekend plans, if you plan to fly off Logan or TF Green, especially on Saturday, you want to be sure to monitor the forecast very closely. And it's so we have high confidence we're going to get something, a winter storm this weekend, but the precipitation type will be highly dependent on the storm track, and it is a storm that has not even formed off the Carolinas yet. So folks have, we are not going to show any deterministic snowfall maps in this presentation, but they are out there on social media. All we can say is that, if you want a reliable source of information for this system, or really for any weather system, be sure to follow someone authoritative, and take whatever extreme amounts out there with a huge grain of salt. It doesn't mean that we cannot get a lot of snow, but we just we are still ways out, and we're still not in the time frame of the NAM, or the high resolution ensemble forecast. That's 48 to 60 hours. So be patient, and we will keep you informed. So be sure to follow our forecast closely if you have any plans this weekend. So like I said, the exact track and the strength of the storm still has to be determined, and the precipitation type and accumulation. And folks, don't just focus on the potential snowfall. With such we know if the system is as strong as some of the models are showing, we have to be concerned about storm force wind gusts for the mariners, and maybe even hurricane force wind gusts are not out of the question, and possible coastal flooding, especially with the Saturday afternoon high tide, because the wind is going to be from the northeast, and the seas will be building, and then we have relatively high astronomical tide. All this combined can give you minor to moderate coastal flooding. So if you live in any of the coastal communities, be sure to monitor the forecast as well. And again, consider alternate plans if you have any planned activities, especially outdoor activities, travel plans, Friday night through Saturday night. So this was the key messages from Weather Prediction Center, whom we work closely with, and whom we'll be working very closely with for the next few days. At this point, all we can say is that confidence is increasing that a significant winter storm can cause considerable impacts Friday through the weekend, really. Just up the mid-Atlantic seaboard into New England. And heavy snow is most likely in parts of New England. If you have any travel plans to areas like DC and Philadelphia, New York City, they could still get heavy snow, but there's a lot more uncertainty the further south you go, especially south of New York City. And significant coastal impacts, like I say, are possible, including coastal flooding and beach erosion. And additionally, strong winds can cause blowing snow and some structural damage as well, depending on how strong the winds gust. And again, be sure to keep checking your local forecast at weather.gov. You can always get your latest forecast at our website, weather.gov/Boston. And so this is a surface map from WPC, and you can see, it's this is 7 a.m. Saturday, and again, high confidence we're going to get a pretty a potentially significant winter storm. But the million-dollar question here is the storm track. A further inland track is going to put again, potentially heavy snow axis further inland, maybe across western Mass into western Connecticut. But whereas if you have a storm track that kind of like tracks over what we call the benchmark, which is 70 degrees west, 40 degrees north benchmark, that is the benchmark we use to determine whether the Providence-Boston corridor is going to get heavy snow. Now, if it takes that storm track and and it potentially intensifies to the extent some of the models are showing, then yes, we could get a lot of snow in the I-95 corridor. Now, there's also the possibility it could track further offshore, south and east of the benchmarks. And if that's the case, then we're going to get a lot less snow. So it really depends on the storm track. And we still have time to figure that out. But again, it looks like there will be at least some kind of impact this weekend. So for leading up to the storm, today was a relatively mild day, but we're gonna get much colder air coming in overnight tonight into tomorrow, Wednesday. And you can see here the minimum temperature forecast. That's actually Thursday morning. You can see that's actually real temperature. So we have sub-zero temperatures in the interior. Like Route 2 corridor, -10 in Orange, -3 in Fitchburg, and then even down to the Massachusetts coastal plains, you can be flirting with 0. So this is what we call an injection of Arctic air prior to the storm, and if and this is actually why if we get the right storm track, this could be one of the more significant winter storms in recent years, because you're going to have abundant cold air to begin with, and then now you get a lot of moisture potentially, basically dumping the moisture into this fresh Arctic cold air. You're going to get you could get a lot of snow out of this. So again, Friday night into Saturday, again, high confidence in the coastal storm, and it really depends on the storm track. If it tracks closer to the coast, areas along the Cape and Islands, even I-95 corridor is going to have some mixing issues, and that's going to cut down the snow total. And but if it is further offshore, and you could get a lot less snow as well, because the snow will be falling over the ocean. But we do have high confidence that the time is going to be between Friday night into throughout much of Saturday. And at this time frame, it is important to be probabilistic in the snowfall forecast. And on the left hand side, you can see the chance of 6 inches or more of snow. And we have a broad brush area of 60% probability of 6-inch plus snowfall across basically the eastern 2/3 of southern New England, and then actually lesser amounts towards the Cape Cod and the islands, because they could potentially have mixing issues. And if you are in western Massachusetts, Connecticut River Valley, you're kind of a little bit too far inland. But again, depending on the storm track, this 60% probability could actually be shifted further west. And at this time frame, the model, the error in an average model is about 100 miles. So you can see why this heavy snow axis could shift. And if you look on the right hand side, actually, there's actually a pretty good probability of a foot or more of snow. And again, right now, using a blend of the models, it's kind of showing the Boston to Providence corridor towards Cape Cod Canal. But again, don't focus on the exact placement of this highest probability, because this highest probability could shift further west or further east, but the potential is there. So, we mentioned about the potential for heavy snowfall, but because this could be a very strong system, and with the high winds and the building seas, you could get minor to moderate coastal flooding. So taking a look at, so that's the Boston tide forecast, and so this 10.59 is actually the astronomical tide, and so that's actually Saturday morning. So notice that's actually the higher of the two tide cycle for Saturday. So you have 8.95 for Saturday afternoon. Now, Saturday morning, even though you have high astronomical tides, the seas and winds are expected to be a little bit less at that time. So, so we were thinking at this point, Saturday morning high tide, maybe minor coastal flooding. The more problematic high tide would be the Saturday afternoon high tide. So if you live in a coastal community, you want to be on, monitor the tide forecast closely. And at this point, it looks like the afternoon high tide will cause more issues than the morning high tide. But either way, you're going to have 1 to 2 feet of inundation possible, with significant beach erosion, and even actually residual minor flooding and splashover on Sunday morning, especially Cape Cod Bay. So at this point, we let's see what time it is. At this point, we'll just take any questions that you have. So let's take a look at the questions. So we have this question from Bob. So any thoughts on the role of the weak low in the Ohio Valley that has moved westward in the forecast models? So this one, so Bob, it sounds like this question is about the potential westward shift in the models. So my 2 cents is that at this point in time, given we are still 72 to 96 hours away from the potential storm, this is something what we call a windshield wiper effect. Don't be surprised that the models can still come back east. But if you want snow in eastern Massachusetts and Rhode Island, you kind of want the storm to again, the low pressure to track over the 70-degree west, 40-degree north benchmark. But at this point, don't be too focused on or don't be too worried about a southern westward shift or eastward shift. They're going to bounce back and forth as the models, because the storm still hasn't formed yet. So the models, once the storm forms, the models will have a much better handle on what is actually happening, and that will reflect on the model output. So hopefully that answers your question. And then we have a question from Ethan. So in terms of interpreting probabilistic maps of any kind, like the chance for X amount or higher, should you be looking at the probabilities around where you are on the map? So I'm assuming the maps are not super high resolution, or focus on the probability for exactly where you are. Rob, do you want to take a stab at that?
Yeah, I would say the answer is kind of both. You definitely want to look at how high the values are, and you also want to look at where the values are. I guess just on the first part, seeing how high they are kind of gives you the confidence of what potentially this storm could bring. So, in the briefing Rodney just gave you, right, there was kind of a bullseye over the South Shore. And remember earlier when I was presenting, talking about the January 7th storm, there was a bullseye over the South Shore. Things ended up being a little north and west in there. But seeing those high values still gives you confidence that, somewhere in the vicinity, there's going to be the potential for that much snow. And then, you do want to pay attention to where they are geographically, because that can kind of give you an idea of, where you potentially think the greatest impacts are going to be.
Yeah, thank you, Rob. Great answer. So we have a question from Wayne. This makes me smile. So which model do you find most accurate for our region? So Wayne, I think, it really, I would say that, especially at this time frame, the major models, are no surprise, the GFS, the European and the Canadian model. We also look at the UK Met as well. Depending on which website you use, you can get information from the UK Met. I think all the models, especially at this time frame, are pretty robust. They are all very good. If not, we will not be using them. But when you get to 72 hours, especially 48 hours, I've personally find that the high resolution ensemble forecast that actually Rob presented on, and actually, in fact, we used a lot in our winter weather reviews and actually also severe weather. We put a lot of emphasis on the HREF, and just because it is, as the name suggests, it is an ensemble of the high resolution forecast. So some of you may have heard of the HER model, the NEM-NES or NEM 3 kilometer. We also have the NERSA-WORF model run by the SPC, and all these models, they give very fine resolution, but sometimes they might be overly aggressive in a certain outcome, for example, showing too many storms, especially in the summer convection environment. So the href really does a good job of not only doing an ensemble, but actually do it over 2 time periods. So earlier on, I talked about the windshield wiper effect. So if you average out the model output over 2 time period, you can smooth out a lot of the noise. So doesn't mean it is perfect, but it's especially as forecasters, we all of us, we love weather. I myself, I love snow, but does that mean that I go with the most aggressive model? No, but I have to objectively look at the models, and using my meteorological knowledge and understanding of the atmosphere, I need to come out with the most realistic model, while also communicating the reasonably worst case scenario, or even what could go wrong. You get a shout out. So it's always interesting, and I would encourage all of you to read our area forecast discussion. So if you go to our website, you can find that, and we discuss a lot of the nuances with the forecast. We put out an official forecast, but if you read our forecast discussion, you can get a better idea of what we were thinking when we did the forecast. Rob, do you have anything to add to that question? Which model do you find most accurate for our region?
Yeah, Ronnie, I mean, I echo a lot of what you said. It really depends on the situation. In the long term, I really don't have a preference because we have all these ensembles. I'm not going to focus on what one model is saying when, you have these ensembles where you get 50 different runs of the same model. I want to know what the average of that is, or where the most chunk of those ensembles is pointing to in the long term. And I guess, as far as ensembles go, I don't have a preference between the Canadian or the GFS or the Euro. They all have their moments. But in the short term, yeah, I mean, like you said, the href model is great. Some of the higher resolution models have their own uses in southern New England. So, for example, in the summertime, I think Rodney had mentioned the WRF model that's developed by the National Severe Storms Laboratory, or the NISA WRF, that does a pretty good job with convection in our area. And then, in the wintertime, the North American Mesoscale, the nested model, they have the high resolution NamNest 3-kilometer model. That's done a pretty great job with some of the ocean effect snow that we've seen in the last couple of weeks. And not sure if anyone remembers, a couple of weeks ago, we had that really impressive lake effect snow band that extended all the way from Lake Ontario into portions of southern New England. And it was only very light snow flurries associated with that, but I thought it was really impressive that the NamNest was able to pick up on that. So that's been kind of my model of choice with respect to kind of low end, light snow events this winter time. And then, with that last storm, the storm we talked about today, the RAP model, the rapid refresh model, that did a great job picking up on that intense snow band over Connecticut and Eastern Mass, probably 12 to 18 hours before the event happened. And as you mentioned, Rodney, I was working when I updated the forecast, and I put a lot of stock into the RAP model for how well it was starting to resolve that band. So, they all have their different strengths in different situations. But in the long term, I think we prefer kind of the consensus or the ensembles.
Oh, thank you, Rob. I think we are on the topic of models, so there's actually a related question. So from Ethan, is there a list of known biases for models that is publicly available? What do you think, Rob?
Yeah, there definitely is. I honestly don't know where they are, but they're out there. I want to say like the GFS. I don't know if it's been corrected in the most updated version, but I'm pretty sure it had a cold wet bias at one time. But that information is definitely out there. There are known biases, and even at the office, we have some locally known biases among the models that some of our IT experts have found ways to kind of add corrections to them in certain situations. So bias correction is a big thing with the models, and I think if you do dig deep enough, you can probably find where the biases lie, but I think they're out there.
Yeah, thank you, Rob. I would add a quick point that if we were to get some of the more, if we get to get a decent snowfall this weekend, then I can tell you straight off the bat that some of the models will be too warm with the daytime highs and overnight lows after the storm, because the models still have to understand the fact that there's a snowpack on the ground, and it would be because of the albedo effect, the heat being reflected off the surface. Daytime highs are going to be lower than some of what the models suggest, but assuming we get a decent snowpack this weekend, we shall see. So Fred asks, in the longer term weather forecast, is it going to be more snow or warmer? I would take that. So Fred, climatologically, we are entering the snowiest part of winter. But also climatologically, we are also on the upswing as well. And you notice that the daylight has been getting longer. And so, looking at the long range forecast, 6 to 10 days outlook. So if you look at the CPC website, so we are running a little bit short of time. Not going to show you the website, but if you go to the Climate Prediction Center website, you can see the 6 to 10 day outlook favors warmer than average temperatures. So if you're tired of the cold, it's kind of weird seeing the ponds iced over, but there's no snow on the ground. But it's been cold. I mean, but if you're tired of the cold, you're gonna like the 6 to 10 day outlook. And so from Eric, by Thursday evening, would the forecast for Saturday's storm be reasonably accurate? Quick answer, yes. Especially by then, we will get into the high resolution ensemble forecast time frame. From Ethan, is a retrograding low a possible concern with this system? So Ethan, I would say there's a non-zero probability. And so for those of you who are wondering what's a retrograding low, basically it's you have a low pressure system that comes up the coast, and then it slows down, and sometimes it even does a loop before it moves away. So that would be one of the more extreme scenarios. But given what we've seen, that's not entirely out of the question. One thing is that if that were to happen, and again, there's still so much uncertainty, and that's just one of the scenarios. And if that were to happen, you're going to significantly prolong your period of precipitation. So, so instead of the opposite would be kind of like a progressive system, like the one we talked about, January 7. Granted, it was even though it was progressive, it dumped a lot of snow in a short period of time. If you were to get a retrograding system, or a system that kind of stores out or is very slow, then you're going to get a much prolonged period of precipitation. So hopefully that answers your question. And the reason why we could have this scenario is because there's going to be some kind of higher latitude blocking. Some of you might have heard about the Greenland block. So basically, if there's blocking, high pressure to the north, it kind of slows down the storm and prevents it from kind of like just going out to sea, So the jury is still out. We shall see. And then let's see. So I think that's all the questions that you have, and really, the time now is 8 p.m. So if you have any further questions or feedback about how we can do better, what you like, or any other topics that you want to hear about. For example, we did a webinar on thunder snow a few weeks ago. That was from one of your feedback. Let Joe know. His email is on the screen, or you can also get his email address from the confirmation email you have for the webinar. So once again, thank you so much for your attendance, and thank you, Rob, for your time. And please stay safe. Follow the forecast closely. Make sure you follow an authoritative source. I cannot emphasize this enough. There's a lot of, I've seen a lot of, most of us are on social media, so we have seen whatever you see out there, we have most likely also seen it. So, especially at this time frame, if you go with some of the extreme scenarios, this 99% you're going to be wrong. So, doesn't mean it cannot happen, but you've got to be realistic. And always remember, if possible, look at the 500 millibar chart. The key is where the storm goes negatively tilted. That would affect where the possible heavy band of precipitation set up. And yeah, so we shall see what happens. So I think again, that's all the questions. So thank you so much, and well, have a great evening, and we'll see what happens.
Thanks, Rodney. Thanks, everyone.
Thank you. Yeah.